Good morning, children. Welcome to the online classes of our Regina School. My dear children, I am suffering from cold, so if my voice is not clear to you, please forgive me. Okay. Today's our topic is atmospheric pressure. So this is the doubt of a student, so I want to explain clear to everyone. What are the topics we are learning in this today's session is what is atmospheric pressure, how big is the atmospheric pressure, and variation of pressure with height, atmospheric pressure and weather. What is atmospheric pressure and weather, and how do we measure the pressure? That means with what instrument? Is there any instrument? If it is so, what do we call that instrument? Like this we will learn. Okay now. So see here children, I am showing you a magic show. So here a magic show is happening. I think every of you were interested in this magic show. Okay, even myself also. So children, here the magician is pouring some water in a glass, and using a paper he flipped it, that is he inverted the glass tumbler. Now look at closely how the magician is doing this. You can observe here even a single drop of water is not falling on the ground, and moreover, so even water is not coming. And what is really happening behind this? Is there any science or it is simply magic? Okay, look at here, I am showing you with arrow marks. The water is not falling on the ground because of atmospheric pressure. Okay, so what is this what actually is atmospheric pressure? Okay, what actually is atmospheric and how big is atmospheric pressure? See here my dear children, when we move out of this when we move into the surface, sorry, out of the surface of earth, that is when we are moving into the space, see the globe is like this. Whatever the air that is surrounding the globe is nothing but atmosphere. In air different gases are there, not only oxygen, carbon dioxide, nitrogen, helium, neon. So many gases are there. Okay, I told you in my first session itself, all these gas molecules are gas particles, tiny particles are placed far from each other so that they are moving in a constant, okay, in a constant speed. Now they will collide with each other. Like that the pressure is created. Now it is measured above the sea level, my dear children. See here I am showing you, take a column near the sea, and what will be the pressure if you measure 10 power 5? Okay, 10 power 5. Now if you really, if you look at a 10,000 stone is falling on you, you feel like that, but are you feeling actually are you feeling really like that? The pressure itself, how it is, a 10,000 kg weight stone is falling on you, it's not easy. So but still you are not feeling that pressure. Why? Because we all know in our body there are veins. In that veins many fluid like blood, water, everything will flow. Okay, now those blood or water in veins will create some pressure equally and opposite to the atmospheric pressure, so that is why we are not feeling any pressure. Now if a person is moving to the higher altitudes, suppose a person is climbing Everest or something, we know many people will climb Everest. Okay, so what is happening, how the pressure is at height, how we are able to sustain at heights if there is atmospheric pressure? Yes, there is a atmospheric pressure at height, but our ears, see, in our ears we feel zzz, like this sound we will feel. Some air, wind is flowing now, that wind will we feel in our ears, that is zzz, like this sound we will feel at higher altitudes. That means why we are feeling, actually our ears are creating equal and opposite pressure to the atmospheric pressure. That is why person who is climbing to the higher altitudes is able to sustain. Okay, still if we go move up, that is not now, still now we have studied a person climbing Everest. Okay, okay, Everest. Now we will see a person who climbed into the space without any that is space suit. So what happens, see here I am showing you some space suit Why the person is wearing? If the person is not wearing this atmosphere space suit, so the pressure, why, however, you will don't have atmospheric pressure in the space, there is no atmosphere, so that is why your veins will get ruptured due to the blood flow. In order to balance that pressure, we are wearing a specialized designed spacesuit. Okay now, my dear children. Now, pressure and weather, we will see what is the pressure and weather. See, in hot air, in desert areas, especially, you know, Thar Desert, Rajasthan, and some desert areas, African countries, there the pressure, heat is more. So when the heat is more, the gases will expand more. That means the distance between the inner molecules or atoms is much. So they will move with more speed and they will collide with much faster. And what about pressure and weather at cold areas? Air in cold areas is very less. Very less. All the molecules or atoms are close to each other. So that is why when, however, you know, the space close to each other in the sense the space is less compared to hot air. So when they are closely tightly bonded, there is a pressure in that. So due to increase in that pressure, definitely the wind flows from cold air to hot air. My dear children, you can observe when you observe, see in cold areas, I told you, when you move, climbed Everest or something else, sound you will observe. Why? Because there the pressure is more and wind moves like that. So how we are measuring this pressure actually? Using a barometer. So the instrument used to measure the pressure is barometer. Who invented this? Torricelli. The scientist name is Torricelli. Actually, see, observe here in the figure, the instrument is like, the barometer is like just like thermometer only. Inside the barometer you will have mercury, okay, mercury filled, and down there is a container. So that container is also filled with a high density liquid, that is mercury. Whenever you flipped this barometer or some just you flipped or raised up, definitely the liquid in the barometer, that is mercury, will come down into the that okay, into that tin or something else where you placed. Now some liquid is came and the vacuum is created or vacuum is appeared in the barometer. As vacuum is created, see my dear children, the difference in the height of atmosphere liquid, the difference in the height of liquid is changed. That is nothing but change in that height is atmospheric pressure. Now take the example of a YouTube barometer. Okay, but beside that we are using a gas. Okay, we are using a gas container. In that gas is there with high pressure. Now when you place the pipe inside to the barometer, see, you are observing the change in the difference of heights of barometer. Are you observing? There is a change in the heights of barometer. One side it is raised, that is left side it is raised, and the right side, the pipe where it is placed, there the pressure is more. So that is why the height is decreased. Okay, now see here, to in order to find the pressure we have a formula. So don't worry about that formula. Pressure is equal to, okay, density of the liquid, gravitational force, okay, like that we will multiply. But don't worry about this formula. In higher studies you will learn this formula. Now it is no need. Okay, so for high pressure, till now we have seen with high pressure, if we decrease the pressure in the YouTube barometer, what happens? There is a change, but the atmospheric pressure is less. Okay, till now we have seen what is atmospheric pressure. Okay, atmospheric pressure is nothing but pressure exerted by the air in our surroundings. How it is measured? Using a barometer. I am coming in the anti-clockwise direction, my dear children. Observe here, in cold areas the pressure is high. Why? Because the molecules are placed close to each other compared to hot air conditions, and the pressure is low in hot areas. So when we move into the higher altitudes, the pressure is reduced. Okay, when we move into the higher altitudes, the pressure is reduced. Why? Because there, when we are going up, the atmosphere is decreasing. So that is why, see, in the space you don't have an atmosphere, there atmospheric pressure is zero. But coming to the, so we all know stratosphere, ionosphere, troposphere, like this. There are atmospheric levels on atmospheric levels. So based on each level you have certain atmospheric pressure. Fixed atmospheric pressure is defined by the scientist. So according to that you will find atmospheric pressure. So when you are moving up, when you are moving into the higher altitudes, you feel that atmospheric pressure is less, my dear children. That is why you will take oxygen cylinders, a special suit, something, everything you will take when you are moving higher altitudes. Like this we will take oxygen cylinders like this. And when we are diving in the sea or swimming pool, a sea especially under, when we are going deeper, we use suit, separate suit, oxygen cylinders. All these are in order to equalize the pressure under the water. Okay na? Is pressure exerted by air on the surrounding. Okay, measured using barometer or a manometer. The instrument name is barometer or manometer. Okay, this is what about atmospheric pressure. Now we will see the same pressure on solids, pressure exerted by the solids. We all know different types of states of matter. In that, one is solid. So what are the topics we will cover here? That is, see here my dear children, topics: pressure exerted by the solids. Okay, what is the pressure exerted by the solids? How much pressure they are exerting? Okay, like this we will see. Okay now see children, factor and what are the factors affecting solid pressure, and some mathematical formula it is there, and practical applications. Okay, but practically where we see the solid pressures, everything we will see here now, my dear children. Just when you move back in at some 15-20 years back or 10 years back, okay, what students or children at that time used to do is they used to play like this. See here, so swing, they will swing using a tire or some wooden box, they wooden piece they will use, and they will tie a rope to the tree and they will swing like this. Now it is ready made with iron we are seeing, but in olden days they used to do like this. When the kid, see, when the kid swinged, there is no damage. But when the father is swinging, you are observing the father has fell down. Why? What is the reason behind the breaking of that wooden piece or that wood trunk? Okay, here the wood trunk that is broken is really very small in area. Okay, small in the area, it is capable to handle the pressure exerted by the kid, but it is not able to handle the pressure exerted by the father, that is elder man. Okay, see, see here I am showing you clearly. See the swinging, red color mark. When father is swinging, it broke. Why it is breaking like that? Why the father has fell down? See, is there any reason behind it? Definitely you know that the pressure exerted by the father or so adult human is more compared to the children. Children's weight is different, father's weight is different. Let us assume father weight is some 60 or 70 kgs weight, children might be some 30 to 40 kgs only. So that is that there is a weight difference in solids. Okay, now when the rope is tied to a big trunk or big wooden trunk, there the father is able to swing easily and happily, because when you observe here, pressure is that is but force acting on per unit area. What is the formula of pressure? P equal to F by A, force per area, that is Newton per meter square. Area unit is meter square, force unit is Newton. Force formula, if you ask, F equal to MA, you know that. So as the area decreased, when the rope is tied to the small wooden trunk, the area is decreased and the pressure is high. So that is why automatically the pressure exerted by the dad or adult human is more. That is why it broke. When the same rope is tied to the bigger trunk, bigger wooden trunk, then father is able to swing happily and easily. It is because the pressure area is increased. So when that is, I already told you, pressure formula P equal to F by A, inversely related. Pressure and area is inversely related. Inversely related, P equal to 1 by A. So as the area decreases, pressure increases. So as the area increased, pressure decreases. So when the rope is tied to a bigger wooden trunk, definitely the area is increased. So the pressure is decreased, my dear children. I told, okay na. That is why the father is able to swing happily. What is the unit of pressure? P equal to F by A, that is force, Newton per meter square area. What is force? Mass into acceleration. Okay, mass into acceleration. What is acceleration, what is motion, or what is mass? We will study in motion chapter, next topic. Okay, some other examples we will see in solid case. See here, my dear children. So when you put more articles in a bag, definitely the rope which is hanging on your shoulders, if the area of that rope is more, definitely it can handle the pressure. If it is small, what happens? Definitely due to the more weight or pressure, area is decreased na, definitely it will cut, or okay na, it will cut into two. Take the example of a needle, my dear children. Observe the needle's head. It is very very sharp and it is very small. Why that area is decreased in that way? Why can't it be like a huge round cylindrical shape? Because due to the decrease in the area, it can penetrate into the wooden piece easily. That means pressure we are applying is more. Okay, thank you, my dear children. I hope all you understood well, my dear children. Okay na. With this we have successfully completed our first